Okay, so once again, very good afternoon all. So in the today's lecture, we will start with the next topic, that is next chapter, that is chapter number 5, shear force and bending moment diagrams. Okay, so this is the next chapter from the section number 2. So in the last lecture, we have covered the chapter number 4, that is torsion of the circular shaft, and now directly we have shifted to the second section, and from that second section we are having the chapter number 5 as a shear force and bending moment diagram. Okay, so this particular section number 2 is totally related with the beam structure. If you see the chapter number 5, it is related to the Sfd and Bmd, and it is related to the beam structure. Then if you see the chapter number 6, again it is related to the bending stresses in the beam. Then chapter number 7, it is related to the beam again, that is shear stresses in the beams. And last, chapter number 8, it is also related to the beam structure, that is slope and deflection of the beam. That means the section number 2 is totally related to the beam structure. And from that, in the today's lecture, we will start with your chapter number 5, that is shear force and bending moment diagrams. Okay, so why we need to study this particular beam structure in this particular strength of material, that we will discuss in the today's lecture. And in addition to that, why we have to calculate the shear force, why we have to calculate the bending moment, what is meant by the shear force diagram, what is meant by the bending moment diagram, how it is to be calculated, which different types of beams we are using in the application, that all the basic introduction parts we will see in the today's lecture. Okay, so if you look at to the title of the chapter, that is shear force and bending moment diagram. Before moving to the diagram, first of all, we need to discuss about the shear force and bending moment and why it is particularly taking place. Okay, so this chapter is mostly, or it is totally related to the beam structure, and you know about the beam. So beam is one of the horizontal structure, you know about in our home also. In so many applications you have seen that particular beam structure in the civil construction. Okay, so that beam is subjected to the number of loads. That beam is subjected to the number of loads, and as that beam is subjected to the number of loads, so that beam is subjected to the shear force and bending moment. If there is no load on the beam structure, no shear force will be developed, no bending moment of the beam is taking place, and we are unable to calculate the shear force and bending moment which are developed in the beam, or we are unable to check the strength of the beam. If we have to check the strength of the beam structure, at that time it is necessary to calculate the shear forces induced in the beam structure and bending moment induced in the beam structure. Therefore, what is the first condition? That beam should be subjected to the some amount of forces. It may be subjected to the point load, it may be subjected to the uniformly distributed load, it may be subjected to the UVL, any load that beam is to be subjected, and due to that particular number of loads, there is a possibility of development of shear force, there is a possibility of development of bending moment, and that values we have to calculate in this particular chapter number 5. At each and every point, whatever the number of points are present on the beam structure, at that each and every point we have to calculate the shear force value, and we have to calculate the bending moment value. And then by using that shear force and by using that particular bending moment calculation, we are drawing one diagram. जी काय shear force ची व्हॅल्यू आपण काढलेली असते, जी काय bending moment ची व्हॅल्यू आपण काढलेली असते, that value are using to draw one figure, or that values we are using to draw one diagram, and that diagrams are called as a shear force diagram and bending moment diagram. And by observing that SFD and BMD, we can easily find out that what are the critical points in that particular beam structure. We have to check the strength of beam. Means that beam has to sustain the maximum amount of load. Okay, in our home also, the beam structure is there. Okay, in our home also that beam structure is there, and that beam is subjected to the number of loads. एकावर जर बिल्डिंग आपण बांधत गेलो, means there is a possibility of increasing the load. First floor, after the first floor there is a second floor, so that first floor is having some beams, so that the beams from the first floor, they are sustaining the load of the second floor. Then again on the second floor we are increasing the third floor, means whatever the beams are present in the second floor, they are sustaining the load of third floor, means the first floor beam is sustaining the load of second floor and third floor. So like that, if the load is continuously increases, at that time there is a possibility of bending in the beam. But without bending, that beam has to sustain the maximum amount of load. Means we have to check the strength of that particular beam structure. Therefore, purposefully, this particular chapter, that is SFD and BMD, it is added in your syllabus of mechanics of material. Now, in the chapter number 1, we have discussed all the basic components. Some two-dimensional bodies are there, some two-dimensional bodies are there, then some three-dimensional bodies are there, then some rectangular sections are there, some square sections are there, some circular sections are there. So all those sections, they are subjected to the external load, and accordingly, we have calculated tensile stress, compressive stress, deformation, elongation, like that. All parameters we have calculated in the chapter number 1. Means we have checked their strength. Again, in the second chapter, that is in the strain energy, we have calculated the amount of energy stored in that particular material. Means again, we have checked their energy storing capacity in the form of strength. Then in the chapter number 4, that is torsion, in that we have checked the strength of the rotating shaft in the form of torque transmitting capacity, in the form of power transmission capacity, in the form of their diameter calculation, in the form of their theta. So we are calculating this number of parameter, means we are checking the strength of that particular material. Similarly, in this particular chapter number 5, that is SFD and BMD, we need to check the strength of the beam structure. That beam may be made by the various materials. So in the civil constructions, it is made by the some cement concretes. In the civil structure, the beams are made by the civil concretes, or cement constructions, or mixture of that cement, then that all this number of particles are there. In our mechanical structure, some beams are made by cast iron, sometimes it is made by the alloy steels, as per the number of applications. Okay, so wherever we are using such a horizontal structures in the form of beam, at that time it is necessary or it is compulsory to calculate their shear force value, to calculate their bending moment value. And we are calculating these values, means we are checking the strength of that particular beam structure. And this SF calculation, BM calculation, we are going to discuss in this particular chapter number 5. Okay, so if you go through their content, so this is the total content of this particular chapter. So what is the content? So first, concept of the shear force and bending moment. Concept of the shear force and bending moment. So why shear stresses are developed? Why bending moments are developed? That we are going to discuss in this particular chapter. Okay, then after this particular basic introduction, we are going to discuss about the different types of beams, which are the types of beams are used in the various types of application, what are the types of loads, what are the types of supports, that also we are going to discuss in this particular chapter. And at the end, we are going to solve the numericals. If there is a simply supported beam, how to calculate SF and BM, or how to calculate the shear force value, how to calculate the bending moment value. If there is a cantilever beam, then how to calculate the shear force value, how to calculate the bending moment value. If there is an overhanging beam, then how to calculate the shear force, how to calculate the bending moment. So that we will discuss at the end whenever we are solving the numericals. But before starting the numericals, it is necessary to understand the basic definition of the shear force, basic definition of bending moment, why they are developing in the beam structure. In addition to that, what are the different types of beams? What are the different types of loads? What are the different types of supports? So that we are going to discuss initially, and then we will solve the numericals. Because to solving the numericals, the procedure for the simply supported beam, cantilever beam, and the overhanging beam is totally different. There is a common procedure we are using for the simply supported beam and the overhanging beam. What is the process we are using for the simply supported beam? Same process it is applicable for the overhanging beam. But the process of SF calculation and BM calculation for the cantilever beam, again it is different. We have to use some standard sign conventions. If you are able to understand that particular sign conventions, then you can solve any type of problems based on SFD and BMD. So one by one, first of all, we will finish all the basic introductory part, all the important definitions, all the standard rules, all the types of loads, all the types of supports, like that, all the basic information. First of all, we will cover in this particular chapter, and then by using the respective sign conventions, we will solve the numericals based on the SFD and BMD. And this is the total content in front of you, which we have to cover in this particular chapter number 5, that is SFD and BMD. Okay, so this is the content. Now we'll start with the introduction part, SF and BM. So before going to the SF and bending moment, that SF means shear force and BM means bending moment. Okay, before going to this particular basic introduction, first of all, we will discuss about the beam structure. Beam is the structural element. Please keep in mind. If I will write here, beam. So beam is the structural element. Beam is equal to beam is also called as a structural element because it is one structure. If you see our construction, in that construction, so many elements are there, so many structural elements are there. For example, column is there, beam is there, then slab is there. So by combining all this particular structural element, your construction is finished. Or you will get one room. If you see our room or if you see our home, in that home, slab is there at the top side, columns are there in the vertical direction, beams are there in the horizontal direction. So these are the structural elements which are designed for the particular load. So beam, column, slab. So these are the some structural elements which are designed for the particular load. And out of that, from this particular beam structure, slab structure, or from that particular column structure, this beam structure we have taken for our syllabus in order to check the strength of that particular beam element. Therefore, that beam is one of the structural element which is subjected to the number of loads simultaneously. The beam is one of the structural element which is subjected to the number of loads simultaneously. That means at the same time, the beam is subjected to the point load, the beam is subjected to the UDL, beam is subjected to the UVL, beam is subjected to the couple. If the number of loads we are applying on that particular beam structure, there is a possibility of bending. There is a possibility of bending. Means, for example, if suppose one rectangular bar is there and that bar is subjected to the external load. If suppose one rectangular bar is there and that bar is subjected to the external load, due to that external load, there is a possibility of development of tensile stress if that load is tensile. There is a possibility of compressive stress if that load is under compression. Means if there is a load, something is happening in that particular body and that we are calculating. Similarly, in this particular beam structure element, if that beam is subjected to the number of loads simultaneously, एकाच वेळी number of load जर त्या बीमवर ऍक्ट झाले असतील, at that time there is a possibility of bending, and how the bending is taking place, that I will explain through this particular figure number 1 and through this particular figure number 2. So now first of all we will discuss about the figure number 1. So what is that particular figure indicates? So one beam is there. So what is the name of that particular beam? Beam AC. One beam is there, that is horizontal structure. That beam AC beam is there, that is
simply supported beam.
This is the simply supported beam. Okay, why it is called as simply supported beam, that definition also we will discuss afterwards. But now you just imagine that this is the simply supported beam, means it is supported at point A, that is at the left side, and similarly it is supported at point C at the right side. Okay, so two supports are there. One is at the left side, another is at the right side. Okay, and that beam is subjected to the two loads. So at the point B, you can see at the center point, this is the point B, this 1000 kg load is applied. This 1000 kg load is applied. Also here, this type of load from point B to C, one load is applied, that is called as the UDL. That is uniformly distributed load. So what is the definition of uniform distributed load? That also we will discuss whenever we will start with that particular definition. Now for this introduction purpose, you just imagine that the beam is subjected to the number of loads. So now in the figure number 1, two loads are applied. One is point load at point B and another is UDL from point B to point C. That means two types of loads are applied. Okay, so due to this particular number of loads applied, bending of the beam is taking place. So like this. At the bottom side, this is called as a bending of beam. This is called as a bending of the beam is taking place. Why it is bending is taking place in the downward direction? Because whatever the point load is applied at point B, it is also moving in the downward direction, and whatever this particular UDL is applied on the beam from point B to point C, that is also moving in the downward direction. Therefore, the bending of the beam is also taking place in the downward direction. And in addition to that, whatever the point load is applied, whatever the UDL is applied, this point load and this UDL are always perpendicular to the axis of beam. Beam is horizontal structure. A beam कसा आहे? As a horizontal structure. If it is horizontal, then its axis is also horizontal, like this. This is supported at the two ends. आणि ह्या horizontal वर जर आपण असा एक point load apply केला, P. This point load is perpendicular to the axis of beam. This point load is perpendicular to the axis of beam. Therefore, on the beam structure or on the beam element, whatever number of loads we are applying on it, that all the types of loads are perpendicular to axis of the beam. Please keep in mind. जेवढे काय लोड आपण बीम वर ऍक्ट करतोय, ते सगळे लोड त्या बीमला कसे, त्या बीमला किंवा त्या बीमच्या ऍक्सिसला कसे असतात तर perpendicular असतात. And that is also visible in the figure number 1. That is, figure number 1 is the simply supported beam, and it is supported at left side, it is supported at the right side, and it is subjected to one point load at the center point, and from point B to point C, one more load is applied, that is UDL, and these two loads are perpendicular to the axis of beam, and due to these two loads are acting in the downward direction, the bending of the beam is taking place in the downward direction. And why this particular bending is taking place, and whatever this particular bending is taking place in the downward direction, it is mostly depends upon the four parameters. Whatever the bending of the beam is taking place in the downward direction, it is mostly depends upon the four parameters. Out of that, first one is the amount of load, amount and type of load. This is the first parameter. जे काय बीमचं बेंडिंग होतंय खालच्या डायरेक्शन मध्ये, डाऊनवर्ड डायरेक्शन मध्ये, तर ते कशावर डिपेंड आहे? तर टोटल 4 पॅरामीटर्स. त्या 4 पॅरामीटर मधला पहिला पॅरामीटर म्हणजे अमाउंट अँड टाइप ऑफ लोड. हाऊ मच अमाउंट ऑफ लोड इज अप्लाइड? नाउ हियर इट इज अप्लाइड 1000 kg. UDL किती आहे? 200 kg. 1000 जर मी 2000 केलं, अगेन देयर इज अ मॅक्सिमम पॉसिबिलिटी ऑफ बेंडिंग. ह्या 200 चं जर मी 400 केलं, अगेन देयर इज अ पॉसिबिलिटी ऑफ बेंडिंग increases. Means The bending of the beam is mostly depends upon the amount of load. किती quantity मध्ये load apply केला आहे, that is also plays very important role while calculating the bending of the beam. Then type of load. Which type of load is applied? Whether point load is applied, whether UDL is applied, whether UVL is applied, whether couple is applied. So which type of load is applied, that also plays very important role. Then second, type of beam. Type of beam. Which type of beam we are using in the application, whether that beam is simply supported, whether that beam is overhanging beam, whether that beam is cantilever beam, or whether that beam is fixed beam, or whether it is continuous beam. Which type of beam we are using for that particular application, based on that also bending of the beam will be variable. Please keep in mind, the bending of the beam is also variable according to the which type of beam we are using for the particular application. Then third, length of beam. Length of beam. What is the length of beam? If it is very large, for example, this is one beam which is supported at the two ends, and त्याच्यासमोर एक दुसरा beam काढतो मी बघा. Okay, so this is the beam number 1 and this is the beam number 2. So the first beam is having length, for example, 100 centimeter, and the second beam is having length only 10 centimeter. So now, in which beam the maximum bending is taking place, whether 100 centimeter length or in 10 centimeter length beam? In which beam maximum bending is there?
10 centimeters.
100 centimeter.
100 centimeter. What about others?
10 centimeters.
10 centimeter. Okay, any another answers? You can send an answer in the chat box. In which beam maximum bending is taking place? 100 or 10? Yes, I want answers in the chat box. Okay, 100. One answer I got. Again? Okay, 100, 100, 100. 100 centimeter. Okay. I think everyone's imagine is 100 centimeter. Okay. Correct answer is 100 centimeter. 10 centimeter is not that, as compared to the 100 centimeter length beam. Minimum bending is taking place in the 10 centimeter. Because why? Because if you see the figure number 1, the length is 100 centimeter means it represents the distance between two supports. So this is the support at the left side and this is the support at right side. And this is the 100 centimeter distance. This is the 100 centimeter distance from left support and the right support. Similarly, in the second beam, again there is a left support, again there is a right support, and distance between these two supports is the only 10 centimeter. Okay, so in this particular 100 centimeter length, there is no any support present at the center point or some near to the left support or near to the right support. जेवढी बीमची लेंथ तुमची जास्त असणार आहे तेवढी त्याचं बेंडिंग होण्याचे चान्सेस काय असतात, जास्त असतात. Because there is a reason. Because what happened, this particular beam structure, it is also having some their own weight. This beam structure is having their own weight, and that own weight is also sometimes acting in the downward direction. The weight of the beam is always due to the gravitational force. Their self weight is always acting in the downward direction. And if you see the support, there is a distance between two supports is very high, 100 centimeter. And middle ला त्याला कुठला support नाही. त्यामुळे if I am applying some amount of load on this particular first beam, immediately there is a possibility of bending. Because due to the maximum distance between the two supports, that much strength that beam will not get to support that particular load. Please keep in mind. ह्याच्यामधलं दोन्ही मधलं डिस्टन्स मॅक्सिमम असल्यामुळं जरी तुम्ही स्मॉल क्वांटिटी मध्ये जरी लोड अप्लाय केला तर त्या दोन्ही मधलं डिस्टन्स मॅक्सिमम असल्यामुळं दॅट बीम इज नॉट सस्टेन द रिक्वायर्ड अमाउंट ऑफ लोड. But in the second beam, the distance between two supports is only 10 centimeter. Okay, so if I am applying some amount of load on this particular second beam, some amount of bending is taking place, but it is less as compared to the beam number 1. Why? Because two supports are very near to the each other, therefore the two supports simultaneously sustain that particular load which is applied on the beam. जेवढी त्या बीमची लेंथ जास्त असेल तेवढी त्याची बेंडिंग होण्याचे चान्सेस काय असतात, जास्त असतात. आणि जेवढी बीमची लेंथ तुमची कमी आहे तेवढा तो मॅक्सिमम लोड काय करतो, सस्टेन करतो. दॅट्स वाय आपण बघितलं असेल इन सम ऑफ द ऍप्लिकेशन, इफ लेंथ ऑफ एनी स्ट्रक्चर इज इन्क्रीजेस, एखाद्या स्ट्रक्चरची लेंथ जर वाढत जात असेल तर एका ठराविक लेंथ झाली की लगेच त्या ठिकाणी आपण सपोर्ट टाकतो. अजून ठराविक लेंथ झाली की लगेच आपण दुसरा सपोर्ट टाकतो. अजून थोडी लेंथ वाढली की आपण लगेच त्याच्या ठिकाणी तिसरा सपोर्ट टाकतो. सो व्हाय इट इज लाईक दॅट? बिकॉज दॅट पर्टिक्युलर स्ट्रक्चर इज डिझाईन फॉर द पर्टिक्युलर ऍप्लिकेशन. त्यामुळे त्याची एक ठराविक लेंथ त्यांनी कॅरी आउट केली की त्या ठिकाणी लगेच आपल्याला त्या ठिकाणी दुसरा सपोर्ट द्यावा लागतो. इफ वी आर नॉट गिव्हिंग द सपोर्ट आणि त्या बीमवरचा जर लोड इन्क्रीज झाला तर देयर इज अ पॉसिबिलिटी ऑफ फेल्युअर. And therefore we need to increase the number of support. आणि त्यामुळे जेवढे तुम्ही सपोर्ट तुम्ही तुमच्या बीम मध्ये इन्क्रीज करसाल, जेवढे तुम्ही सपोर्ट वाढवसाल तेवढं त्या बीमची लोड कॅरिंग कॅपॅसिटी काय होणार आहे, वाढणार. That's why this supports plays very important role, and in addition to that particular supports, length of the beam plays very important role. So please keep in mind, if the length of beam is maximum, there is a possibility of maximum बेंडिंग. जेवढी बीमची लेंथ तुमची जास्त असणार आहे तेवढी त्या ठिकाणी बेंडिंग होण्याचे चान्सेस काय असणार आहेत, जास्त असणार. अँड इन दिस पर्टिक्युलर एक्झाम्पल, सो द लेंथ, द बीम हॅव्हिंग 100 सेंटीमीटर लेंथ, there is a maximum bending possibility as compared to the second beam having length 10 centimeter. Therefore length of beam is also plays very important. And the fourth parameter is mostly important, that is elasticity. Elasticity of the beam. What is meant by the elasticity? What is meant by the elasticity? If we are applying the load on any component, if we are applying the load on any component, the dimensions of that particular body will get changed, or deformation of body is taking place. When deformation is possible? If that body will be the elastic body. If that body is totally rigid, then we will not get any type of deformation. Therefore the beam is also one of the elastic structure where after application, after applying number of forces on that particular beam structure, there is a something changes. Bending of the beam is taking place. Means what happen exactly? Bending of the beam is taking place means the original position of the beam will get changes. Bending of the beam is taking place means original position of the beam is taking place. And why it is taking place? Because whatever the material is used to that particular beam structure, that material will be the elastic material. जर आपण बीम वर लोड अप्लाय केला असता आणि त्या बीम मध्ये काही चेंज झाला नसता, then we are unable to calculate the shear force and bending moment. मग आपल्याला बीम हा रिडिझाइन करायची गरजच लागली नसती. जर बीमचं जर बेंडिंग होतच नसलं असतं तर त्याच्यावर आपण किती जरी लोड अप्लाय केला असता तर तो बीम त्या ठिकाणी बेंड झालाच नसता. बट इट इज नॉट लाईक दॅट. एव्हरी इलिमेंट इज हॅव्हिंग देअर ओन लिमिट. प्रत्येक इलिमेंटला किंवा प्रत्येक स्ट्रक्चरला त्याचं ओन लिमिट आहे. आपल्याला जर 5 मजली बिल्डिंग बांधायची असेल तर ऍट दॅट टाइम फर्स्ट ऑफ ऑल वी नीड टू डिझाइन द बीम स्ट्रक्चर. एकावर एक दुसरा, दुसऱ्यावर तिसरा, तिसऱ्यावर चौथा, लाईक दॅट नंबर ऑफ फ्लोर्स वी आर इन्क्रीजिंग अँड अकॉर्डिंग टू दॅट वी नीड टू डिझाइन द बीम स्ट्रक्चर. आणि तुम्हाला एकच घर बांधायची असेल, एकच खोली बांधायची असेल तर ऍट दॅट टाइम द बीम स्ट्रक्चर विल बी डिफरंट. म्हणजे 4 मजली बिल्डिंगसाठी बीमचं स्ट्रक्चर वेगळं असणार आहे आणि एका मजल्यासाठी बीमचं स्ट्रक्चर वेगळं असणार. Why it is like that? Because your loads are variable and according to the variations in the load we need to redesign the beam structure. And why it is taking place? Because the material of the beam is totally elastic. It is changes according to the type of load. Beam structure is changes their own position according to the number of loads Therefore, elasticity of the material is also plays very important role, and it also plays very important role in the bending of the beam. So you have to keep this particular 4 points in your mind, because based on this the MCQ questions are asking. The bending of the beam is mostly based on, first one, amount of load, type of load, then type of beam, then length of beam, and fourth one is the elasticity of beam. So these are the 4 elements where the bending of the beam is variable. And why the bending of the beam is taking place, I have explained. The beam is subjected to the number of loads. Now the first beam I have given in front of you, that is the simply supported beam. Now if you look at to the second beam, the second type of beam is called as a cantilever beam. Why it is called as a cantilever, that we will discuss in the definition. But just if you assume it, in case of a cantilever beam, left end is fixed and right end is फ्री. पहिल्या बीम मध्ये पॉइंट ए ला पण सपोर्ट आहे आणि पॉइंट सी ला पण सपोर्ट आहे आणि दोन्हीच्या मध्ये लोड अप्लाय झालेला आहे. बट इन द सेकंड फिगर कॅन्टिलिव्हर बीम इज देअर वेअर द लेफ्ट साइड इज फिक्स्ड. त्याची लेफ्ट साइड जर बघितली तर इट इज टोटली फिक्स्ड अँड राइट साइड इज टोटली फ्री. And here the 2 point loads are applied. One load is applied at the center point, its magnitude is 8 kilonewton. Second load is applied at the free end, its magnitude is also 8 kilonewton. Now due to this number of loads applied here in the second figure also there is a possibility of bending. Bending कसं होतं ह्या ठिकाणी. If you compare bending of the beam in figure number 1 and in the figure number 2, there is some change. In figure number 1, at point A and at point C, in figure number A and in figure number 1, at point A and at point C, very less amount of bending is taking place at the supports. जिथे तुमचा बीम तुमचा फिक्स केलेला आहे म्हणजे पॉइंट ए ला आणि पॉइंट सी ला जिथे तुमचा सपोर्ट दिलेला आहे बीमला, at that point very less amount of bending is taking place, but that bending will be maximum at the center point. तुम्ही जर कर्व बघितला खाली आलेला तर maximum bending is taking place at the center point. But if you look at to the figure number 2, one end is fixed, another end is free, and if you see very less amount of bending, or we can consider it equal to 0, or we can consider it as a very less amount of bending is taking place at the fixed side, but the maximum bending will be taking place at the free end, because there is no any support. जर त्या ठिकाणी सपोर्टच नसेल आणि त्या ठिकाणी जर तुम्ही लोड अप्लाय करत असाल तर सपोर्टच नसेल तर देयर इज अ मॅक्सिमम पॉसिबिलिटी ऑफ बेंडिंग. Therefore, there is a basic difference between the simply supported beam and the cantilever beam. How the bending is taking place? In the simply supported, bending is maximum at the center point and it is near about equal to 0 at point A and at point C. But in the second figure, that is in cantilever beam, very less amount of bending, or it is equal to 0 at the fixed support, but the maximum bending is taking place at the free end. So this is the maximum, this is the basic difference between the simply supported beam and the cantilever. That means if we are changing the structure of the beam, एका बाजूला simply supported आहे, दुसऱ्या बाजूला cantilever आहे, means your bending of the beam is also depends upon the types of beam. कुठल्या प्रकारचा बीम तुम्ही ऍप्लिकेशन मध्ये वापरलेला आहे त्याच्यानुसार पण तुमचा बेंडिंग मोमेंट काय असतो, व्हेरिएबल असतो. अँड दॅट वी हॅव ऑब्झर्व्ड बाय कंपेअरिंग फिगर नंबर 1 अँड फिगर नंबर 2. Okay, so this is the basic introduction related to the simply supported beam and cantilever beam, and when they are subjected to the number of loads simultaneously, how the bending of the beam is taking place. And that bending of the beam is mostly depends upon the 4 points, that is amount of load, type of beam, length of beam, and the elasticity of the beam material. So this is related to the basic introduction. Now wherever this beam element is provided, wherever the structure is provided which is looking like a beam element, at that location or at that particular structure, it is necessary, it is compulsory to calculate the shear force value and bending moment value. ज्या ज्या ठिकाणी अशा हॉरिझॉन्टल स्ट्रक्चर दिलेले असतील, दॅट application may be civil construction, that application may be mechanical application. Wherever such beam structures are provided, at that time it is necessary and it is compulsory to calculate the shear force value and to calculate the bending moment value. It is compulsory. And in this particular chapter, we are calculating it. Getting. Now, in addition to that, if you see the loads which are applied on the beam, it is varying from section to section. If you see the number of loads which are applied on the both beams, it is varying from section to section. But in the figure number 1, at point A, one support is there, that is reaction R1. This is reaction means it is also one type of load. This reaction means it is also one of the type of load. It is applied at point A. Then from point A to B, there is no any load. ह्या पॉइंट ए आणि बी च्या मध्ये कुठल्याच प्रकारचा लोड नाही. अगेन ऍट पॉइंट बी वन पॉइंट लोड इज अप्लाइड. Then again from point B to point C, there is a UDL. Again at point C, there is a second reaction. That means whatever the number of loads applied on that particular beam, it is varying from section to section. Therefore, shear force value will not remain constant. Also, bending moment value is also not remain constant, as the type of load or amount of load is varying from section to section. According to that, the value of shear force is also variable and value of bending moment is also variable, and therefore we need to calculate the separate shear force value to the each and every point which are provided on the beam. What I am telling, as the forces are varying from section to section, therefore shear force value will not remain constant, bending moment value will not remain constant. If it is not constant means we need to calculate separate shear force value at point A, separate shear force value at point B, separate shear force value at point C. Similarly, we need to calculate bending moment at point A, bending moment at point B, and bending moment at point C. And similarly, it is applicable for the figure number 2 also. Here at point C, this is the fixed support. At point B, 8 kN load is applied. Then at point A, again 8 kN load is applied. That means again the loads are variable. Again the loads are variable, means again in the second figure also shear force value will not remain constant for all the points, and bending moment value is also not remain constant to the all points. It will be variable, and that variable values we are calculating means we are calculating separate shear force at point C, at point B, at point A. And in addition to that, we are calculating separate bending moment value at point C, separate bending moment at point B, separate bending moment at point A. But from this theoretical calculation, from this particular theoretical calculation, we will not get the idea where the shear force is maximum, where bending moment is maximum, where shear force is 0, and where bending moment is 0. बघा आपण पॉइंट ए ला शेअर फोर्सची व्हॅल्यू काढतोय, पॉइंट बी ला शेअर फोर्सची व्हॅल्यू काढतोय, पॉइंट सी ला पण शेअर फोर्सची व्हॅल्यू काढतोय. तसंच ह्या पॉइंट ए ला पण बेंडिंग मोमेंट काढतोय, पॉइंट बी ला पण बेंडिंग मोमेंट काढतोय, पॉइंट सी ला पण बेंडिंग मोमेंट काढतोय. सो वी आर कॅल्क्युलेटिंग दिस व्हॅल्यू इन द theoretical calculation. We are doing some calculations and we are getting the value. But whatever the values we are calculating, from that value we are unable to give the final decision. We are unable to give the final decision that where shear force is 0 and where shear force is 0, where bending moment is 0 or where bending moment is maximum. कुठे shear force 0 आहे आणि कुठे shear force maximum आहे आणि कुठे bending moment maximum आहे आणि कुठे bending moment 0 आहे. That value we are, or that decision we are unable to find by using the calculated values. So what we are doing, whatever the calculation we are made, that calculation we are converting in the form of diagram. प्रत्येक पॉइंटला जी काही शिअर फोर्सची व्हॅल्यू काढलेली आहे, प्रत्येक पॉइंटला जी काही बेंडिंग मोमेंटची व्हॅल्यू काढलेली आहे, ह्या प्रत्येक व्हॅल्यूचा वापर करून आपण एक डायग्राम ड्रॉ करतोय आणि त्याच डायग्रामला आपण काय म्हणतोय, शिअर फोर्स डायग्राम, अँड अनदर इज बेंडिंग मोमेंट diagram, or in short it is called as a SFD, it is called as a BMD, and in that diagram we are observing the critical points. त्या डायग्राम मध्ये तुम्हाला सगळं समजते की कुठं शिअर फोर्स मॅक्सिमम आलाय आणि कुठं शिअर फोर्स झिरो आलाय, किंवा कुठं बेंडिंग मोमेंट मॅक्सिमम आलाय आणि कुठं बेंडिंग मोमेंट तुमचा झिरो आलाय. That critical points you will get from that particular figures. Therefore we need to study this particular concept in your syllabus as a SFD and BMD of the beams. So this is related to the basic introduction. त्यामुळे जिथं जिथं तुमचा बीम इलेमेंट टाइप स्ट्रक्चर दिलेला असेल त्या ठिकाणी तुम्हाला शिअर फोर्स आणि बेंडिंग मोमेंट कंपल्सरी काढणं गरजेचं आहे. मग ते काढल्यानंतर त्या दिलेल्या कॅल्क्युलेशन पासून आपण इमॅजिन करू शकत नाही की त्या बीमची स्ट्रेंथ कमी आहे का जास्त आहे. मग आपण काय करतो, दॅट कॅल्क्युलेशन वी आर कन्व्हर्टिंग इन द फॉर्म ऑफ डायग्राम. त्या कॅल्क्युलेशनचा वापर करून आपण एक फिगर काढतो, आपण एक डायग्राम करतो. त्याच डायग्रामला आपण काय म्हणतोय, एसएफडी आणि बीएमडी. आणि मग त्या एसएफडी मध्ये आपल्याला कळते की कुठले कुठले तुमचे क्रिटिकल पॉइंट आहेत, कुठं तुमचा बेंडिंग मोमेंट मॅक्सिमम आला. After observing that particular critical points, we need to make the modifications in your design. मग हे क्रिटिकल पॉइंट काढायचे कशाला, जर तुमचा बेंडिंग मोमेंट जर व्हॅल्यू मॅक्सिमम येत असेल, मीन्स देर इज अ पॉसिबिलिटी ऑफ फेल्युअर. त्या पॉइंटला फेल्युअर होण्याचे चान्सेस काय असतात, जास्त असतात. जर एखाद्या पॉइंटला शिअर फोर्सची व्हॅल्यू आणि बेंडिंग मोमेंटची व्हॅल्यू बियॉन्ड लिमिटच्या जर बाहेर चालली असेल, मीन्स देर इज अ पॉसिबिलिटी ऑफ फेल्युअर. सो by taking that reference we need to redesign your beam structure and try to increase their strength. आपल्याला काय करावं लागतो, तो बीम परत रिडिझाइन करावा लागतो आणि त्या स्ट्रक्चरची स्ट्रेंथ आपल्याला त्या ठिकाणी काय करावं लागते, इन्क्रीज करावी लागते. and that we are going to check in this particular chapter, that is SFD and BMD. So this is related to the basic introduction of the shear force and bending moment. Why shear forces are developed, why bending moments are developed, that I have explained. Why? Because beams are subjected to the number of loads. एकाच बीमवर नंबर ऑफ लोड जर ऍक्ट झालेले असतील तर त्या बीम मध्ये शिअर फोर्स पण इंड्यूस होतो आणि बेंडिंग मोमेंट पण इंड्यूस होतो. अँड इट इज नॉट कॉन्स्टंट. प्रत्येक पॉइंटला शिअर फोर्सची व्हॅल्यू वेगळी आहे, प्रत्येक पॉइंटला बेंडिंग मोमेंटची व्हॅल्यू वेगळी आहे. का तर त्याच्यावर अप्लाय झालेल्या लोडचे व्हॅल्यू पण काय आहेत, वेगवेगळे आहेत. मग बाय युजिंग द स्टँडर्ड प्रोसिजर वी आर कॅल्क्युलेटिंग द सेपरेट शिअर फोर्स व्हॅल्यू ऍट इच अँड एव्हरी पॉईंट. ज्या बीम मध्ये जेवढे काही पॉईंट आहेत महत्वाचे त्या प्रत्येक पॉईंटला आपल्याला शिअर फोर्सची व्हॅल्यू काढावी लागते, त्या प्रत्येक पॉईंटला आपल्याला बेंडिंग मोमेंटची व्हॅल्यू काढावी लागते. and that calculation we are converting in the form of diagrams, and that diagrams are called as a SFD and another diagram is called as a BMD. So this is related to the basic introduction of the shear force and bending moment diagram, and why we have to calculate this SF and BM in the beam structure, that also I have explained. Beam हा फक्त सिमेंट कॉन्क्रीटचा नसतो, please keep in mind. Beam is not only made by the cement concrete, that is the civil construction, that is the civil application, but in our mechanical also, in our mechanical application also, some beams are there which are made by the cast iron, some beams are made which are made by the aluminums. So in mechanical applications also such types of the beam structures are there. Therefore at that time also, or at that particular application also, it is necessary to calculate the SF and BM. So this is related to the basic introduction of the shear force and bending moment diagram. Okay, so this is introduction. Have understood this introduction part, what is meant by the SFD and what is meant by the BMD and how it is to be calculated. Just I have given just introductory part, and once again we will discuss in detail what are the types of beam, what are the types of load, what are the types of support, how to calculate the SF, how to calculate BM, that we will discuss laterwards. But now have understood the basic introduction of SFD and BMD and why it is to be calculated. Yes. What about others? Everyone have understood this basic introduction part? If you have any questions, you can ask. You can unmute from your side and you can ask the questions. Okay. I hope everyone has understood. The concepts are very simple and straightforward. Somewhat parts, maybe from the division students, they have studied somewhat part in your first year subject, that is in the applied mechanics, and from B division students, they have also studied this somewhat part in your diploma subject also, that is in the strength of material. So if you look at the figures also, from that figure also you will get the more and more information. तुम्ही नुसतं फिगर जरी बघितला बीमच्या, त्या फिगर वरून आपल्याला जास्तीत जास्त इन्फॉर्मेशन मिळते की this is the beam subjected to the number of loads, then due to that loads bending of the beam is taking place, and that bending we have to calculate, that shear force value we have to calculate. So like that basic introduction you will get from that particular figure also. But in addition to that, some additional part also we are going to take as a type of beams, types of loads, types of supports, sign conventions. So like that also we are going to discuss after this. Okay, so up to this we have studied this particular basic introduction part. Okay, now we'll start with the some important another important points, that is types of beams. So which types of beams are there? So that also we need to understand. What are the types of beams? So these are the different figures I have represented in front of you, and now I will give or I will explain the definition of each and every beam, and that definition how it is applicable to that particular figure, that also we have to understand. Once I will give one definition, how that definition is applicable for that particular figure, or whether the things which are written in that particular definition, whether that definition is satisfying that particular figure or not, that also we need to understand. Definitions are very, very simple. So first, types of beams. So the first, this is the figure number 1. So that beam is called as a cantilever beam. Here I have written figure number A or figure number 1. That beam is called as a cantilever beam, and it is having simple definition. So many times we are using this particular construction, or so many times we are using this particular structure in so many applications. Then what is the definition of cantilever beam? So simple. The beam whose one end is rigidly fixed and another end is free, that beam is called as a cantilever beam. What is the definition? The beam whose one end is rigidly fixed and another end is free, that beam is called as a cantilever beam. Now, how this definition is applicable for the figure number 1? That is the beam whose one end is fixed. For example, this is the left side of the beam and this is the right side of the beam. Okay, the left side of the beam is totally fixed. The left side of the beam is totally fixed, means it is rigidly fixed at one side and another end is free. Now if you see the right side of the beam, here there is no any support, there is no any reaction, there is no any fixed point, means this right side is totally free. And such types of the beam structures are called as a cantilever beam. Simple, the beam whose one end is fixed and another end is free. आता ह्या फिगर मध्ये लेफ्ट साइड फिक्स्ड दाखवले, राइट साइड फ्री दाखवले. In some of the applications it will be exactly opposite. Right side is fixed, left side becomes totally free. So this structure is also called as a cantilever beam. But what is their requirement? एक बाजू फिक्स्ड असली पाहिजे आणि दुसरी बाजू फ्री असली पाहिजे. जर अशी जर कंडिशन त्या बीमला असेल तर that particular beam is called as a cantilever beam. So this is the first definition, that is cantilever beam. Then second figure or figure number B. Second figure or figure number B, it is also called as a simply supported. It is called as a simply supported beam. So what is the definition of simply supported beam? What is the definition of simply supported beam? Can anybody, by looking to the figure? Yes.
The
What
beams
is the
which
definition?
are just rest on its two supports.
Correct. The beam which is just rest on its two supports, that beam is called as a simply supported beam. What is the definition? The beam which is just rest on its support, or it is supported at two ends only. Two definitions are. The beam which is just rest on its support, that beam is called as a simply supported beam. Or what is the second definition? The beam whose both ends are fixed, not fixed actually, the beam which is supported at two ends, the beam which is supported at two ends, that beam is called as a simply supported beam. I will explain the meaning of the first. The beam which is just rest on its support. This is the left support of the beam. खालच्या बाजूला चॉकलेटी कलरचं दिसतंय. This is the left support, and at the right side again this is the right support. This is the left support and this is the right support, and this horizontal structure is called as a beam. This is the beam. What is our definition? The beam which is just rest on its support. जिथं सपोर्ट आहेत त्या ठिकाणी जर तुमचा बीम रेस्ट झालेला असतील तर त्या बीमला आपण काय म्हणतोय? सिम्पली सपोर्टेड बीम म्हणतो. और the beam which is supported at two ends only. जिथं बीम तुमचा संपतोय त्या ठिकाणी जर बीमला सपोर्ट केला असेल तर that beam is also called as a simply supported beam. बघा ह्या सपोर्टच्या बाहेर बीम एक्सटेंड झालेला नाही. जिथं तुमचा सपोर्ट आहे त्या ठिकाणीच तुमचा बीम काय झालेला आहे? एंड झालेला आहे. म्हणजे लेफ्ट साइडला बघा, the beam is end at this particular point where support is provided. At right side the beam is end at the support points only. जिथं तुमचा सपोर्ट आहे त्या ठिकाणीच तुमचा बीम काय झालेला आहे? एंड झालेला आहे. आणि ज्या ठिकाणी बीम तुमचा एंड झालेला असेल आणि त्या ठिकाणी जर सपोर्ट दिले असतील तर that beam is called as a simply supported beam. So two definitions. What is the first definition? The beam which is just rest on its support, that beam is called as a simply supported beam. And what is the second definition? The beam which is supported at the two ends only. ज्या ठिकाणी तुमचा बीम संपतोय त्या ठिकाणी जर त्याला सपोर्ट दिले असतील तर that beam is also called as a simply supported beam. So these two definitions you have to keep in your mind. Okay, then third, this is called as a overhanging beam. This is called as a overhanging beam. If you see the figure number 2 and figure number 3, in figure number 2, in simply supported beam also there is a two supports. In the overhanging also there is a two supports, but there is a basic difference in the figure number 2 and figure number 3, and due to that difference only the figure 3 beam is called as a overhanging beam. So what will be the definition for the overhanging beam?
End portions are extended beyond its support.
Correct. What is the definition of the overhanging beam? The beam whose end portions are extended beyond the support. म्हणजे सपोर्टच्या बाहेर येऊन जर बीम एक्सटेंड झालेला असेल, मग तो एका साइडला असू द्या किंवा दोन्ही साइडला असू द्या, that beam is called as overhanging beam. And it will observe from figure number 2 and from figure number 3. In figure number 2 जिथं सपोर्ट आहे त्या ठिकाणीच तुमचा बीम काय झालेला आहे? एंड झालेला आहे. बट इन फिगर नंबर 3 इफ यू सी देर आर टू सपोर्ट्स. सो दिस इज द सपोर्ट नंबर 1, दिस इज द सपोर्ट नंबर 2. ओके, ऍट लेफ्ट सपोर्ट ऑल्सो द बीम इज एक्सटेंडेड बियॉन्ड द लिमिट. म्हणजे सपोर्टच्या बाहेर येऊन पण तुमचा बीम काय झालेला आहे? एवढा एक्सटेंड झालेला आहे. Similarly at the right side the beam is extended beyond the support. म्हणजे राईट साइडला पण तुमचा बीम काय झालेला आहे? सपोर्टच्या बाहेरच्या बाजूला एक्सटेंड झालेला आहे. तर such types of the beam structures are called as a overhanging beam. मग तो एका बाजूला एक्सटेंड झालेला असू द्या किंवा दुसऱ्या बाजूला एक्सटेंड झालेला असतो. बघा मी इथं खालच्या बाजूला दुसरी फिगर काढतोय. लेफ्ट साइडला एक सपोर्ट आहे आणि इथे एक सपोर्ट आहे. This is the left support and this is the right support. At the left side द बीम इज एंड, जिथं तुमचा बीम एंड झालेला आहे त्या ठिकाणी सपोर्ट प्रोव्हाइड केलेला आहे. पण राईट साइडला जर बघितला तर राईट साइडला सपोर्टच्या बाहेर एका बाजूलाच बीम काय झालेला आहे, एक्सटेंड झालेला आहे. जरी तो एका बाजूला झाला असेल तरी पण त्या बीमला आपल्याला काय म्हणायचं आहे तर ओव्हर हँगिंग बीम. So simple difference we need to understand from figure number 2 and figure number 3. That is, in figure number 2, the beam is supported at the two ends only. जिथं बीम तुमचा संपतोय त्या ठिकाणीच सपोर्ट दिलेला असतील तर त्या बीमला आपल्याला काय म्हणायचंय, सिम्पली सपोर्टेड बीम म्हणायचंय. अँड व्हॉट इज द फिगर नंबर 3? The beam whose end portions are extended beyond the support. It may be at one side or it may be at both side. जरी सपोर्ट दोन्ही बाजूला एक्सटेंड झालेला असेल किंवा जरी सपोर्ट एका बाजूला जरी एक्सटेंड झालेला असेल, that both figures will be called as a overhanging beam. So this is the basic difference between the figure number 2 and figure number 3. फक्त figure number 2 and 3 मध्ये common things काय आहेत? In figure number 2 also two supports are there. In figure number 3 also two supports are there. फक्त फिगर नंबर 2 मध्ये जिथं तुमचा बीम संपतोय त्या ठिकाणी सपोर्ट आहे आणि फिगर नंबर 3 मध्ये सपोर्टच्या बाहेरच्या बाजूला पण बीम एक्सटेंड झालेला आहे, त्यामुळेच त्याला आपण काय म्हणतोय, ओव्हरहँगिंग. देन फिगर नंबर 4 और फिगर डी, इट इज कॉल्ड एज ए कंटिन्यूअस बीम. इट इज कॉल्ड एज ए कंटिन्यूअस बीम. सो ना दिस विल बी नॉट ए कॅटेगरी ऑफ सिम्पली सपोर्टेड बीम. कारण ह्याच्यामध्ये जर बघितलं फिगर नंबर 4 मध्ये जरी बघितलं जिथं बीम तुमचा संपतोय तिथं सपोर्ट दिलेला आहे, but it will not be simply supported beam and it is also not coming under the category of overhanging beam. कारण मधल्या सपोर्टच्या बाहेरच्या बाजूला पण बीम एक्सटेंड झालेला आहे आणि बाहेरच्या सपोर्टचा जर विचार केला तर जिथं बीम संपतोय त्या ठिकाणी तुमचा सपोर्ट दिलेला आहे. So it will not becomes under the category of simply supported and it will also not comes under the category of overhanging beam. Then what will be the definition of continuous beam? What will be the definition of continuous beam?
Which is rest on more than two supports.
Correct. The beam which is rest on more than two support, that beam is called as a continuous beam. Therefore, it is not compared with the simply supported and the overhanging beam. In simply supported and in overhanging, there is only two supports. But in the figure number D, if you see, there is a total 4 supports. So at the left side, this is the support number 1. Then this is the support number 2. This is support number 3. And at the right side, this is the support number 4. That means the beam which is rest on more than two support, म्हणजे 2 पेक्षा जास्त जर सपोर्ट एका बीमला दिलेले असतील तर that beam is called as a continuous beam. That's why we need to understand the basic difference between figure number B, figure number C and figure number D. का फिगर डी ला सिम्पली सपोर्टेड म्हणायचं नाही किंवा का फिगर डी ला ओव्हरहँगिंग म्हणायचं नाही? बिकॉज सपोर्ट्स आर मोर. जर त्या ठिकाणी 2 सपोर्ट असले असते फिगर डी मध्ये, एक तर तो सिम्पली सपोर्टेड मध्ये तर मोडला असता किंवा ओव्हरहँगिंग मध्ये पण मोडला असता. बट instead of giving the 2 supports, there is a total 4 supports, and as per our definition, the beam which is supported more than 2 support, म्हणजे 2 पेक्षा जास्त जर सपोर्ट एकाच बीमला दिलेले असतील तर that beam is called as a continuous beam. This is the simple definition. Then figure number 5, name itself suggests fixed ended beam. There is a basic difference between the figure number 1 and figure number 5. Figure number 1 आपली काय सांगत होती, कॅन्टिलिव्हर बीम whose one end is fixed and another end is free. मग लेफ्ट साइड फिक्स्ड असेल तर राइट साइड it will be free. If right side is fixed, left side will be free. That will be the cantilever. But in the figure number 5, if you see their heading, fixed ended beam means the beam whose both ends are fixed. That beam is called as a fixed ended beam. The beam whose both ends are fixed, that beam is called as a fixed ended beam. And if you see the figure, in the figure the left side is also fixed and right side is also fixed. As both ends are fixed, therefore it is called as a fixed ended. Fixed means fixed condition. Ended means ज्या ठिकाणी तुमचा बीम एंड होतो त्या ठिकाणी जर बीम फिक्स केलेला असतील तर त्या बीमला आपल्याला काय म्हणायचंय, फिक्स्ड एंडेड बीम म्हणायचंय. अँड इन दिस पर्टिक्युलर फिगर द लेफ्ट साइड इज ऑल्सो फिक्स्ड, राइट साइड इज ऑल्सो फिक्स्ड. Therefore that figure number 5 is called as a fixed ended beam. Okay, and last figure number 6 or figure number F, it is called as a cantilever simply supported beam. It is a combination of two beams. It is the combination of two beams. Cantilever simply supported beam. Why it is called as cantilever? Because their left side is fixed. Because their left side is fixed, and at another end one roller support is given. At another end one roller support is given. It is not perfectly cantilever and it is not perfectly simply supported. हा कॅन्टिलिव्हर मध्ये पण मोडत नाही आणि हा सिम्पली सपोर्टेड मध्ये पण मोडत नाही. जर हा कॅन्टिलिव्हर मध्ये आपल्याला कन्सिडर करायचा असेल तर लेफ्ट साइडला फिक्स केलेला आहे पण राइट साइडला एक रोलर सपोर्ट दिलेला आहे. Therefore it is not totally cantilever beam. हा सिम्पली सपोर्टेड पण कन्सिडर करू शकत नाही. का तर एका साइडला तो फिक्स केलेला आहे आणि दुसऱ्या बाजूला रोलर सपोर्ट आहे. पण सिम्पली सपोर्टेड मध्ये फिक्स्ड सपोर्ट हा कधीच दिलेला नसतो. इन सिम्पली सपोर्टेड बीम फिक्स्ड सपोर्ट हा कधीच दिलेला नसतो. एक तर तो रोलर सपोर्ट असतो, एक तर तो हिंज्ड सपोर्ट असतो. म्हणजे हा त्रिकोण जो असतो हा त्रिकोणी सपोर्ट, हा त्रिकोणी सपोर्ट म्हणजे तुमचा हिंज्ड सपोर्ट आहे आणि असा गोल जर दिलेला असेल that will be the roller support. But in the figure number 6, at one side fixed support is there and at another side roller support is there. Therefore this is 50% cantilever and 50% simply support. Therefore this figure number 6 is called as a cantilever simply supported. But such types of the figure number 6 like that structure, it is not mostly used in the particular applications, but just for your more understanding why it is 50% cantilever and why it is 50% simply supported, that we need to understood from this particular figure. जर हा फुल्ली आपल्याला कॅन्टिलिव्हर पाहिजे असला असता तर राइट साइडला आपल्याला रोलर सपोर्ट इट शुड नॉट बी देअर, देन इट इज फुल्ली कॅन्टिलिव्हर. जर हा फुल्ली सिम्पली सपोर्टेड पाहिजे असला असता तर लेफ्ट साइडला आपल्याला हा त्रिकोणी सपोर्ट द्यावा लागला असता, देन इट विल बी द फुल्ली सिम्पली सपोर्टेड. बट इट इज partially cantilever, partially simply supported, and this is a combination of cantilever simply supported beam. So these are the total 6 types of beams. We have discussed their definitions, and in our syllabus, as per our syllabus, we need to calculate Sfd and Bmd for the first beam, that is cantilever beam. We need to calculate Sfd and Bmd for the second beam, that is simply supported beam, and we need to calculate Sfd and Bmd for the third, that is overhanging beam. We as per our syllabus, we are not going to calculate Sf and Bm for the continuous beam, then fixed ended beam and cantilever simply supported beam. Just for your more understanding, just for your introduction of all the types of beams, here I have explained all the 6 types of beams. But for your syllabus, whatever the numericals we are solving, for the numericals we are having only 3 types of beams. One is cantilever, second is simply supported, and third one is a overhanging. But for your examination, whatever your MCQ examinations is there, in that MCQ examination, all these particular 6 types are very, very important, because in your MCQ examinations, the definitions are asking based on the types of beams. One definition is given to you, and that definition is applicable for which type of beam, that we have to check from the 4 answers. Your question will be in the form of definition. Your question will be in the form of definition. We have to read that definition, and according to that given definition, we need to identify which type of beam will be there. Therefore, for that MCQ questions, all these 6 types are very, very important. And these are the basic definitions of all the types of beams. Cantilever, one end is fixed, another end is free. Simply supported, which is supported at the 2 ends, or it is just rest on its support, that is simply supported beam. Overhanging beam whose end portions are extended beyond the support. It may be at one side, it may be at both sides. That will be the overhanging. Continuous means if it is supported more than 2 supports, that will be continuous. Fixed ended means जर दोन्ही बाजू जर फिक्स्ड केलेल्या असतील तर दॅट विल बी द फिक्स्ड एंडेड. अँड कॅन्टिलिव्हर सिम्पली सपोर्टेड मीन्स 50% कॅन्टिलिव्हर, 50% simply supported according to their supports mentioned in the figure, that is called as a cantilever and the simply supported beams. So these are the total 6 types of beams, and out of that 6 we are having the numericals based on the 3, that is cantilever, simply supported and overhanging. Otherwise all the 6 beams are very very important for your MCQ questions or examination. So I hope you have taken these particular types of beams in your figures. If you have not taken, you can put the heading types of beams. Draw all the figures in your notebook immediately. So cantilever, draw the figure. I will give 1 minute. You just take all the types of beams, their structures in your notebook. The definition part I have already added in the notes. I will share that particular notes to you, so you will get all the detailed information, all the important definition through this particular notes. But once you understood the concept through this particular figure, that notes are also not required. If you write the definition as your own, if you understand the concept, तुम्हाला जर concept understand झालेला असेल, and if you are able to write down the definition as per the figure, then also that definition will be accepted. But try to use some standard words in that definitions. It should be 1 or 2 lines. Definition should be 1 or 2 lines. It should not be like paragraphs. So take this particular heading, that is types of beams. Draw the figures only along with their heading. So put the heading and draw the figures only. Okay, finish. I hope you have taken all these particular figures in your notebook. I think my screen is visible. Is my screen is visible to all? Yes, screen is visible or not? Am I audible?
Yes, sir.
Screen is visible.
हाँ, sir.
It may not be visible after a few seconds because there is electricity problem. So I'm unable to share the screen. Just we will wait for 1 or 2 minutes. Meanwhile, you draw the figures. Yes, just I will share my screen. Wait. Am I audible? Yes, now it is audible.
Yes, sir.
Okay, so we are discussing these types of beams. I hope everyone have taken these particular types of beams, their figures in your notebook. Yes, have taken.
Yes, sir.
Okay. Now, so these are the types of beams we have discussed. Now we'll discuss about the types of loads on the beam. So in the first introduction part, we have seen that is one simply supported beam is there and it is subjected to 1 point load. Then another cantilever beam is there. It is also subjected to the 2 point loads. Then in the simply supported beam, one UDL is also there. So that you have seen which type of load is there. But here we need to understand what are the basic definitions of the all the types of loads, and if the type of load, which type of load is mentioned in that particular beam structure, and how it will be used for the further calculation, that also we are going to discuss as a types of loads on the beams. Okay, so basically there is a total 3 types of loads. Basically there is a total 3 types of loads. So first one is a point load, second one is a UDL, its long form is uniformly distributed load, and third one is a UVL, that is uniformly varying load. So basically these are the 3 types of loads and we have to discuss about their definitions. So what is meant by the point load? What is meant by the point load? So here in the figure number 1 I have given, this is the point load. What is the definition of point load? If you see the figure here, one beam is there. So this is the one beam, horizontal beam is there. It is supported at this left side. It is supported at the right side. Similarly, in the second figure also, this is the left support. This is the right support, and this is the point P, which is applied. This is the point P, which represents the point load applied on this particular horizontal structure or on this particular horizontal beam. But it is having one simple definition: the load which acts at a point, the load which is acts at a particular point, that load is called as a point load. Please keep in mind. See, this is the beam AB. Point A, point B. Point A is present at the left side, point B is present at the right side. And here, one more point is present in between A and B. That is point C. Okay, and at this particular point C, the P amount of load is applied. At point C, the P amount of load is applied, and that load is called as a point load. Why it is called as a point load? Because simple definition: the load which is applied at particular point, that load is called as a point load. एका ठराविक पॉइंटला जर एखादा लोड अप्लाय झालेला असेल तर त्याच पॉइंटला किंवा त्याच लोडला आपण काय म्हणतोय, पॉइंट लोड म्हणतोय. After that, again one more point is present in between A and B, for example point D, and at point D, if second load I am applying as a P2, then that second point load is also applied at particular point only. P2 हा C ला पण अप्लाय झालेला नाही. P2 is not applied on A, it is not applied on B, it is applied for particular point on the beam. Therefore, that load is called as a point load. Therefore, simple definition once again I will tell: the load which is applied at particular point, that load is called as a point load. Okay, so this is the first type of load. Then second, UDL. UDL. So what is the long form of that? U means uniformly, D means distributed, and
Distributed
L means
load.
load. That is uniformly distributed load. So what is the meaning of that? What is the uniformly distributed load? So here I will draw one more figure of uniformly distributed load, which we are drawing always. For example, this is one simply supported beam which is supported at point A and it is supported at point B, and it is subjected to uniformly distributed load like this, kilonewton per meter. The beam is having length L. What is the meaning of uniformly distributed load? Name itself suggests that. What is the meaning of uniformly distributed load? The load which is uniformly distributed, or the load which is uniformly spread over the length of beam, that beam is called as a uniformly distributed load. Once again, I will repeat the definition. The load which is uniformly distributed or which is uniformly spread over the beam. Over the beam means total length of the beam. That is from point A up to the point B. From point A up to the point B, if load is uniformly spread, then that load will be the UDL. Means, for example, this is 50 kilonewton meter load, UDL. This is 50 kilonewton per meter. What is the meaning of 50 kilonewton per meter? 50 kilonewton, it is the magnitude, and per meter means length. किती लेंथ वर तो स्प्रेड झालेला आहे तर 50 किलोन्यूटन इट इज अप्लाइड ऑन एंटायर लेंथ ऑफ द बीम. म्हणजे ह्या पॉइंट ए पासून पॉइंट बी पर्यंत तुम्ही कुठला जरी पॉइंट ह्या बीम वर कन्सिडर केला तर त्या प्रत्येक पॉइंटची मॅग्निट्यूड काय असणार आहे 50 किलो न्यूटन पर मीटर. This is the meaning of uniformly spread or uniformly distributed over the entire length of beam. If any point I am considering from point A to B, ह्या point A आणि B मधला तुम्ही बीम वरचा कुठला जरी पॉइंट कन्सिडर केला तर त्या प्रत्येक पॉइंटला तुमची मॅग्निट्यूड काय आहे तर 50 किलो न्यूटन पर मीटर. मीन्स the load which is uniformly distributed, uniformly spread over the entire length of the beam. जेवढी काय ती बीमची लेंथ आहे, फॉर एक्झाम्पल 5 मीटर एवढी जर ह्या बीमची लेंथ असेल, ह्या 5 मीटर वर जेवढा काय लोड ऍक्ट झालेला आहे, द मॅग्निट्यूड ऑफ लोड इज 50 किलो न्यूटन पर मीटर. So this is the definition of uniformly distributed load. The load which is uniformly spread on the entire length, that load will be the uniformly distributed load. But that UDL value we need to convert into point load. If 50 kilonewton per meter ही व्हॅल्यू आहे अशी आपण पुढे कॅल्क्युलेशन मध्ये यूज करू शकत नाही. That UDL value we need to convert into point load. मग अशा UDL चं जर आपल्याला point load मध्ये कन्वर्ट करायचं असेल तर त्याचा फॉर्म्युला आहे that is equivalent point load is equal to W into length. If we need to convert UDL into point load, then their formula is W into length. So what is our W value? 50. What is your length? 5
meter.
Total 250 kilonewton load, and it is always applied at the center point. If we are converting your UDL value into point load, that point load is always act at the center point of the UDL. Now please tell me, what will be the center point of the UDL from point A and from point B?
L by 2.
L by 2, correct. This is L by 2. The center point means this is L by 2. This is L by 2 means 2.5 meter, 2.5 meter. Getting? UDL is always acts at the center point of the length. जेवढ्या लेंथ वर ऍक्ट झालेला UDL तेवढ्याच लेंथचा 50% पार्ट म्हणजे UDL. Now, if I will give one figure to you, for example, see, this is one simply supported beam. Okay, this is point C, this is point A, this is point B. Okay, and this is the UDL. This is 2 meter. Left side is 3 meter. At point C, एक point load पण आहे 50 किलो न्यूटनचा. आणि UDL ची व्हॅल्यू इथे फॉर एक्झाम्पल 10 kilo Newton meter. Now this point load we can take as it is. Now I have to convert this UDL into point load. I have to convert this UDL into the point load. So what will be the magnitude of point load once UDL is converted into point load?
20.
10 into 20. आपला फॉर्म्युला काय? इक्विव्हॅलंट पॉइंट लोड इज इक्वल टू W into length. मग W किती आहे? UDL ची मॅग्निट्यूड काय? 10. लेंथ किती आहे? 2, which is equal to 20 kilo Newton. And it will be acts at the center. मग तुम्ही बीमचा सेंटर घेणार का UDL चा सेंटर घेणार?
UDL.
करेक्ट. दिस इज व्हेरी इम्पॉर्टंट. फक्त घेताना या ठिकाणी यू हॅव टू टेक द सेंटर ऑफ UDL, कारण आपण W इंटू लेंथ काढताना आपण लेंथ किती कन्सिडर केलेले? फक्त 2 मीटर. वी हॅव नॉट कन्सिडर टोटल लेंथ ऑफ द बीम 5 मीटर. आता ह्या फिगर नंबर 1 मध्ये पॉइंट A पासून पॉइंट B पर्यंत टोटल UDL आहे. त्यामुळे ह्या ठिकाणी बीमचा सेंटर पण बरोबर तुमचा L/2 म्हणजे 2.5 मीटरला झालेला आहे. बट इन फिगर नंबर 2 UDL इज अप्लाइड ऑन ओनली 2 मीटर लेंथ आउट ऑफ 5 मीटर. टोटल बीमची लेंथ किती आहे? 5 मीटर आहे. त्या 5 मीटर मधले ह्या 3 मीटर मध्ये A to C मध्ये काहीच लोड नाहीये, पण फ्रॉम C to B देयर इज अ UDL. त्यामुळे या ठिकाणी पॉइंट लोड घेताना 10 into 2 20, and that point load will be applicable in between C and B. That is 1 meter from here side, 1 meter from here. Therefore, L/2 means it is length of UDL divided by 2. It is not total length of beam. In figure number 1, total length will be applicable, L/2. And in the figure number 2, length is applicable where UDL is applied. So this is the uniformly distributed load. So what will be the definition? The load which is uniformly spread over the entire length of the beam, that beam is called as a uniformly distributed load. That is UDL. Okay. Then third, uniformly varying load. See, this is again one beam. This is point A, this is point B, this is point C, and its magnitude is, for example, 10 kilonewton per meter. So AB distance is 2 meter and BC distance is also 2 meters. So what is meant by the uniformly varying load? So what is the definition of the uniformly varying load? So here it is represented in the form of triangular section. Uniformly varying load, it is represented in the form of triangular section. So its definition is the intensity of load is increases or decreases at constant rate, then that load is called as a uniformly varying load. What I have told, the intensity of load is increases or decreases. If I am starting from point C, if I am starting from point C and if I am moving towards point B, C to B, whether load is increased or decreased. From C to B, whether load is increased or decreased. Increased. बघा हा ट्रायंगल असा वर चाललाय. This line is increases like this. Means at point C, load is 0. At point B, load is maximum. Means 50% definition is satisfied. The intensity of load which is increases at constant rate. Constant rate ने increase होते, अचानक वाढत नाही. Slowly it is increases. And what is the second definition? The intensity of load which is decreases at constant rate. मग आता बघा point B ला maximum आहे. मग point B to C whether it is increases or decreases.
Decreases.
Decreases. From point B to point C, intensity of load is decreases, and from point C to point B, the intensity of increases. If such conditions are happening, then such types of the loads are called as a uniformly varying load. त्या नावाचं जर बघा uniformly varying. That means uniform variation is taking place. How? Point C ला 0. त्याच्यानंतर पुढे inclined line म्हणजे थोडा वाढला. Then again increases. Then again increases. Then again increases. And at point B, it is maximum. म्हणजे पॉइंट सी ला 0 आहे. सी नंतर एखादा दुसरा पॉइंट घेतला तर त्या ठिकाणी 2 किलो न्यूटन पर मीटर. त्याच्यानंतर 5 किलो न्यूटन पर मीटर. त्याच्यानंतर 7 किलो न्यूटन मीटर. And maximum point will be 10 kilo Newton per meter. Means it is increases from 0 kilonewton to 2, 2 to 5, 5 to 6, 7, 8, 9, 10. That means uniformly it is increases. Therefore, that load is called as a uniformly varying load. And if we are considering from the maximum point, maximum 10 kilonewton, मग decrease होताना लगेच 10 वरून 0 होत नाही. From 10 it becomes 9, then 8, then 7, 6, 5, 4, 3, 2, and then at point C it becomes equal to 0. That means it is uniformly decreases at constant rate. Therefore, its definition is make in the both way, the load whose intensity is increases or decreases at constant rate, then that load will be called as a uniformly varying load. But this 10 kilonewton per meter, that value we need to consider for the calculation. की पॉइंट सी ची 0 पण आपल्याला कन्सिडर करावी लागत नाही, किंवा ह्या पॉइंट बी टू सी मधले जे काही छोटे छोटे पॉइंट आहेत, that also we need not to consider. Whatever the maximum point is there, 10 kilonewton per meter, that value only we need to consider for the calculation. But we cannot take as it is. जसं UDL मधली 50 kilonewton per meter, 10 kilonewton per meter, that value, UDL value we have converted into point load. Similarly, this UVL value also we need to convert into point load, and their formula is somewhat different. That is equivalent point load for UVL is equal to WL divided by 2. So what is the value of W? 10. What is the length? 2 meter divided by 2 factor. This 2, it will get cancelled. You will get load as a 10 kilo Newton. UDL मध्ये काढताना आपला फॉर्म्युला काय होता? W into L. दिलेल्या UDL च्या व्हॅल्यूला फक्त आपल्याला काय करायचं होतं? लेंथ मल्टिप्लाय करायचं. UVL च्या ह्याच्यामध्ये काय आहे? W into L तर आहेच, आणि त्याच्या खाली फक्त काय केलेलं आहे त्यांनी? डिवायडेड बाय 2 केलेलं. मग UVL ची व्हॅल्यू W घेताना म्हणजे कुठली घ्यायची? जी काय मॅक्सिमम पॉइंटची व्हॅल्यू आहे, 10 किलो न्यूटन असेल, 50 असेल, 100 असेल, दॅट व्हॅल्यू यू हॅव टू टेक. लेंथ कुठली घ्यायची? की जेवढ्या ह्याच्यावर UVL आहे, म्हणजे हा पॉइंट बी पासून पॉइंट सी पर्यंतच UVL आहे, and its length is 2 meter. Therefore it's 2 and divided by 2 as it is. This 2 जर कॅन्सल केलं तर आपला UVL चं पॉइंट लोड मध्ये कन्वर्ट करून तुमची मॅग्निट्यूड काय आली तर 10 किलो न्यूटन. Because that kilo Newton meter value we cannot take as it is in the further calculation. It may be UDL, it may be UVL. So we need to convert that UDL into point load by using the formula. For the UDL, equivalent point load is equal to W into length, and for UVL, equivalent point load formula is equal to W into L divided by 2. Okay, this is the point load converted. Then where it is acts, जसं UDL चा point load मध्ये convert केल्यानंतर it will be applied at L by 2 distance from the left side and L by 2 distance from the right side. जसं UDL मध्ये आपण बरोबर तो सेंटरला घेतो, UDL च्या बरोबर सेंटरला घेतो, तसं what about UVL? What are their distances? So that distances are L by 2 and 2L by 3. L by 3 and 2L by 3. Please keep in mind L by 3 and 2L by 3. So where is L by 3 and where is 2L by 3? That also we need to understood. That I will just wait. So here I will draw the both figures. This is UVL, okay, and this is also UVL, म्हणजे opposite side, okay. So this is 10 kilonewton per meter, its length is 2 meter, ह्याची पण लेंथ 2 मीटर, हा पण 10 kilonewton per meter वर आहे, ठीक आहे. Now we need to convert that into point load. मग काय करणार मी, W into L divided by 2, म्हणजे 10 into 2 divided by 2, 2 it will get cancel. This is 10 kilonewton point load. Similarly खालच्या बाजूला पण मी काय केलं, it will be converted into point load, म्हणजे इथं पण तुमचा लोड किती आला, 10 kilonewton. So this 10 kilonewton force it will not be at center of the 2 meter. जसं UDL मध्ये आपण सेंटर घेत होतो, but in UVL it is not at the center point. So that distances will be, see, this is point A, this is point B, this is point A, this is point B. So for the first figure, it will be L by 3 and this will be the 2L by 3. And for the second figure, this will be L by 3 and this will be the 2L by 3. Understood? L by 3 from which side and 2L by 3 from which side? L by 3 म्हणजे कुठल्या साइड नाही बघा, जिथं तुमची मॅक्सिमम मॅग्निट्यूड आहे बघा, हा पॉइंट A पहिल्या फिगर मध्ये, पॉइंट A म्हणजे तुमची मॅक्सिमम मॅग्निट्यूड आहे, आणि त्या मॅक्सिमम मॅग्निट्यूड पासून तुमचा अप्लाय केलेला पॉइंट पर्यंत तुमचं L by 3 डिस्टन्स असणार आहे, म्हणजे काय असणार आहे इथं 2 by 3, आणि त्या पॉइंट लोड पासून मिनिमम पॉइंट पर्यंत जे काय डिस्टन्स आहे दॅट विल बी 2L by 3, म्हणजे 2 into 2 divided by 3. तेच UVL आपण ऑपोजिट डायरेक्शन मध्ये घेतलं, म्हणजे इन द फिगर नंबर 1 मॅक्सिमम व्हॅल्यू इज प्रेझेंट ऍट द लेफ्ट साइड, बट इन द फिगर नंबर 2 इफ यू सी द मॅक्सिमम व्हॅल्यू इज प्रेझेंट ऍट पॉइंट B, म्हणजे ही मॅक्सिमम साइड आहे तुमची राईट साइड. मग ह्या राईट साइड पासून आपल्या पॉइंट लोड पर्यंत डिस्टन्स ते किती आहे, L by 3, म्हणजे इथं पण काय येणार 2 by 3, आणि त्या पॉइंट लोड पासून तुमच्या 0 पॉइंट पर्यंत डिस्टन्स म्हणजे काय 2L by 3, म्हणजे 2 by 2 divided by. So these figures are very very important. In UDL this concept will not be applicable. जेवढा काय तुमचं UDL आहे 3 मीटरचा, 3 मीटरचा UDL असेल तर त्याचा हा 50% म्हणजे 1.5 meter from left side, 1.5 meter from right side. That means L divided by 2. But in case of a UVL, it is not at the center point. In case of a UVL, it is not at the center point. It will be the L by 3 from the maximum side and 2L by 3 from the 0 point side. So these are the different types of loads which we have to use in our further calculations. What is the point load? The load which is acts at the particular point, that load is called as a point load. What is the UDL? The load which is uniformly spread over the entire beam, that load is called as a uniformly distributed load, and it will be converted into point load by using the formula W into L, and it will be acts at the center of the UDL, that is L by 2. Then what is the uniformly varying load? The load whose intensity increases or decreases at constant rate, that load is called as a uniformly varying load, and it will be converted into the point load by using the formula WL divided by 2, and it is not acts at the center of the UVL. There are two distances. Which are the distances? L by 3 from the maximum side, त्या त्रिकोणामध्ये जी काय मॅक्सिमम साइड दिसत असते त्या मॅक्सिमम साइड पासून तुमच्या पॉइंट लोड पर्यंतचं डिस्टन्स L by 3, and it is same for both the figures. पहिल्या फिगर मध्ये पण ह्याच साइड पासून आहे, दुसऱ्या फिगर मध्ये पण ह्याच साइड पासून आहे. फक्त पहिल्या फिगर मध्ये L/3 हे इकडच्या बाजूला आलेलं आहे, दुसऱ्या फिगर मध्ये L/3 इकडच्या बाजूला आहे, because maximum side is changes. So these are the three types of loads, and the fourth type of load is also there, which is called as a couple. But couple is not the type of load. Couple means force into perpendicular distance. लोडचं युनिट काय किलो न्यूटन किंवा न्यूटन मध्ये असणार आहे, बट कपलचं युनिट काय असणार आहे, फोर्स इंटू डिस्टन्स मीन्स एकतर किलो न्यूटन मीटर किंवा न्यूटन mm. Because definition of couple is the force into perpendicular distance. So force is measured in kilonewton or Newton. Distance is measured in meter or mm. Therefore, its unit is kilonewton meter. Therefore, it will not be considered as a type of load. Couple is the force into perpendicular distance, and the effect of couple will be considered in the bending moment calculation only. Coupleचा इफेक्ट आपण shear force मध्ये कधीच consider करत नाही, because shear force we are calculating in kilonewton or Newton, and bending moment we are calculating in kilonewton meter or Newton mm. Therefore, the effect of couple will be applicable in the bending moment calculation only. So these are the total 4 types of loads which we have to use in our further calculation of SF and BM for all the types of beams. Okay, getting all the types of loads, what are the definition of the types of loads and how it is converted into the point load, and what are their important distances for the UVDL and UVL once that values are converted into the point load. Everyone have understood?
Yes, sir.
Okay, what about others? Everyone have understood? If you have not understood, you can ask the questions. सगळ्यांना समजलंय का? What is the difference between all the types of loads? UVDL आणि UVL मध्ये differences काय आहेत? Everyone have understood? दोन्ही UVDL आणि UVL ला आपल्याला point load मध्ये कन्वर्ट करावं लागतंय. फक्त UVDL चा फॉर्म्युला W into L आहे, UVL चा फॉर्म्युला W into L divided by 2 आहे. UVDL च्या ह्याच्यामध्ये पॉइंट लोड मध्ये कन्वर्ट केल्यानंतर इट इज इक्वल टू L/2, म्हणजे लेफ्ट साइड पासून पण तेवढंच डिस्टन्स, राईट साइड पासून पण तेवढंच डिस्टन्स, फक्त ते कुठलं डिस्टन्स जेवढ्यावर UVDL आहे तेवढंच. डोंट कन्सिडर द सेंटर ऑफ बीम. जर सगळ्या बीमवर असेल तर इट इज सेम, नो प्रॉब्लेम. अँड इन केस ऑफ UVL, फ्रॉम विच साइड इट इज L/3 and from which side it is to L/3, that we have to understood. L/3 कुठल्या बाजूला आहे, ज्या बाजूला UVL ची मॅग्निट्यूड मॅक्सिमम आहे त्या साइड पासून तुमच्या पॉइंट लोड इंडिकेट केल्यापर्यंत तुमचं डिस्टन्स L/3 आणि राहिलेलं डिस्टन्स तुमचं 2L/3. So these are the different types of loads which are applying on the beams, and that we need to consider for our further SF calculation and the BM calculation. Okay, everyone have understood? Still I'm not getting the replies from each and every students. If you have not understood, you can ask the questions. You can unmute from your side, or you can ask the questions in the chat box. Once again, I'm asking, everyone have understood or not? Okay, so now I hope everyone has understood as per your replies, and still if you have not understood, you can ask the questions anytime. I will explain that particular concepts, I will explain that particular definitions, whatever you have not understood again and again. But you need to understand this particular all the concepts very well, because that concepts we need to use for our further calculation. तुम्हाला जर हे जर कन्सेप्ट कळाले नाही कसं कन्वर्जन करायचंय आणि कसं ते कुठल्या डिस्टन्स वर रिप्रेझेंट करायचंय, then you are unable to solve the numericals based on this particular SF and BM. So for point load it is very simple. For UVDL also it is very simple. The formula पण simple आहे आणि त्याचं डिस्टन्स पण L/3. But sometimes there is some confusion of UVL. कुठल्या बाजूला L/3 आणि कुठल्या बाजूला 2L/3. That's why I have represented both the figures in front of you. UVL ह्या बाजूला मॅक्सिमम आणि ह्या बाजूला जरी मॅक्सिमम असला तर कुठलं डिस्टन्स कुठल्या बाजूला रिप्रेझेंट करायचंय, that you have to understood. Okay, I hope you have understood, and with this today we will stop here. In the next lecture we will take the remaining part. Okay, thank you.